Hi, this is Pat Kelly.
Okay, in this problem, they give us an f of x and they give us a g of x, and they're asking us to practice our composition concept. So we're supposed to find f composition with g, g composition with f, and also g composition with itself. Okay, so definitely a good idea to practice a lot of. So the thought process I'll use here should get you through the other problems similar to it. What you want to do is f composition g. Let me start with realizing that that's actually a function. So just for notation's sake, I like to say f composition with g of x. And it's really because the definition of that, and this is what you want to make sure you're getting down as you're doing these problems, the definition of this is f of g of x. Okay? So you start with knowing that definition, and then maybe a little bit of a reality check. From here, what you want to recognize is that this is just function notation. This is f of something. So I go up to my f function, and f of whatever the argument is, I put that argument right there where I see the x. All right? So back to our problem, this equals, my f function starts with a cube root, and then right away is the argument. But instead of x, I plug in the argument here, which is all of g of x. X cubed plus 1. Put parentheses around that for organization if it helps, because that's the argument that I'm seeing in my f of in the step before. Now where was I? Here in the f function, there's still subtract 1 under the radical hat. Finish that off there. Okay? That step was key in terms of understanding what's going on. Now it's algebra, as usual, so we want to clean it up a little bit. This cleans up kind of nicely because those parentheses aren't actually doing anything. They were just there for organization. So right away I can do plus 1 minus 1. That's 0. So this is going to equal the cube root of x cubed, which equals just x. You're done. Part B. This time we're going to do g composition with f, which, again, by definition, it's a function. And it's a function that's defined this time as g of f of x. Just make sure you're getting that order down. And the order is actually exactly as you would read it from left to right. So g composition with f is g of f of x. Now back to function notation. This time the argument is going inside the g function. So here's the g function, and the argument is just cubed and then plus 1. So in my work, I'm going to say equals. My argument is all of f of x, so I'm going to grab the entire expression, cube root of x minus 1. Okay, and then that's just here. Let me even do that same kind of squiggle. That's the argument here, so I still need to cube it because in the g function, the argument was cubed. And I'm still in the g function, I got to remember the plus 1. Okay, and again, that's the key step. Understand what's going on there. And then there's the algebra steps. So my algebra here, notice what you have in the parentheses is actually a cube root that we're cubing. So it actually just gives you what's inside the radical, x minus 1. And you don't want to forget the plus 1 that's there. And you can see one more simplification step is you're just going to get x, right? Okay, now that will not always happen. My f of g, my g of f, both ended up equaling x. They're actually trying to foreshadow something that you'll see soon. But let's continue with part C, g composition with itself. So I still want to start by understanding that what that means in terms of notation is g of x. That sounds redundant, but the inner g of x is your argument that you're going to plug into g of x. So I start by looking at my g of x function, but realizing my argument is the entire g of x function. So I'll write the entire g of x function. I'll use my squiggle coding again for you. That's just the argument that I have here. I still need to cube it, and then plus 1. Okay? And then it's the algebra. The algebra here, I'm going to expand a binomial to the 3 power. So in this case, that's going to end up being x to the 9th plus 3x to the 6th plus 3x cubed plus 1. Take your time on that one if you even need to write another step or two to expand those parentheses. Then I still have, maybe I'll put parentheses, that's just the binomial to the 3 power. I still have my plus 1. I do have to take one more step, but there's not much going on. I'm just going to combine the only like terms of those constants. So this equals x to the 9th plus 3x to the 6th plus 3x cubed plus 2. But that would be my final answer. Okay? These problems are all different. Don't look for patterns. Just know your setup and then algebra. Algebra, algebra. Well, make sure you practice, as always.